All right, let's take a look right away at our second example using the substitution method. So we have over here something that looks very similar to our first example, except two different equations. So once again, we're trying to figure out what is the point of intersection for these two lines. And instead of having to go through the whole process of graphing these two lines, hoping that they intersect at an easy location, and then figuring out what that location is, we're going to use the substitution method. Now remember, if you need to follow along with the steps, you can look back at the steps that you hopefully just took down in your notes. So step one was that we choose one of our two equations and we solve that equation for one of the variables. Now it doesn't matter which equation we choose, and it doesn't matter which variable we solve for. We always want to go with the simplest solution. I know sometimes that surprises people when I say that, but really we don't want to overcomplicate this. So what is the easiest variable here to solve for? I think that it's y, and I think that because in the first equation, y is all by itself. So in order to get y isolated, I just need to move negative 2x over. So let's do that. Let's take, I'm drawing with the eraser, that's why it's not drawing. That's better. We're going to move, we're going to add 2x to both sides, which will leave me with y equals 2x plus 6, or 6 plus 2x, however you want to write that. So what I've just determined is that the value of y is the same as 2x plus 6. If I were to put this on a balance, on a scale, y would weigh exactly the same amount as 2x plus 6. So anywhere I see y, I can replace it instead with 2x plus 6. Which is what my step 2 is. I'm going to go to my second equation and I'm going to rewrite it 4x minus 2y, but instead of y, I'm going to replace it with 2x plus 6 equals 5. So we need to simplify that. Well, actually, that would be our step 3, so maybe I should change my color. That was step 1 and 2. Step 3, we just solve for x, because now I have an equation with one variable. And as long as there's only one variable, we can solve and find a numeric solution for it. So let's distribute our negative 2. So we'll have 4x minus 4x, because that's what negative 2 times 2 is, and then minus 12, because it's negative 2 times 6, equals 5. So let's solve this out. 4x minus 4x, well, that just is 0x, and I have, oh my goodness, what is happening here? Negative 12 equals 5. Now, if you think I must have just done something wrong, because that is just absolutely ridiculous, negative 12 never equals 5. Like, what's the problem here? Negative 12, it's not even like 5 equals 5. Negative 12 equals 5. What is going on? Well, let me tell you. This is a solution or a system of equations that has no solution. And I wanted to throw this example in because I want you to know what will happen in the situation where two lines never intersect. So remember we said that two lines could intersect once. That would be one solution. That's what happened in our last example. Or we could have two lines that are parallel. That means they never intersect. And so in that case, there are no solutions. And that's what just happened here, because we got negative 12 equals 5, and that's not even true. Negative 12 never equals 5. If it comes up with some sort of answer that doesn't make sense mathematically, the answer is no solution. And that's all you have to write, is just no solution. And then our third situation is that we could have two lines that are essentially the same line. That means they overlap infinitely many times. And so we have infinitely many solutions. And before we end this video, I'm going to show you what that kind of example looks like. So take a look at this before I erase it. We have, again, we went through our process, we isolated a variable, we plugged that into the other equation, we went to solve for x in this case, and we got a nonsense statement. If the answer is nonsense, like negative 12 equals 5, the answer is just no solution. Okay, that was our second example. Let's see what happens. I'm going to tell you ahead of time, this is an example of where there are infinitely many solutions. But I want you to see algebraically what happens when that, or what that looks like when it happens. So we have 3x minus y equals 4, and we have negative 9x plus 3y equals negative 12. So this is our system of equations. All right, same process. We're going to choose one of the equations to solve for one of the variables. And once again, I think that the easiest variable to solve for is y, and I think it's easiest to solve for in the first equation. So I'm going to do that by subtracting 3x from both sides, which will give me negative y equals negative 3x plus 4. And then in order to complete that, I would have to divide each term by negative 1. So that would make this positive y, this is positive 3x, and this would be negative 4. Because remember, when we divide everything. So we have our substitution equation. Y is the equivalent of 3x minus 4. So let's take that and plug it into the second equation. So we'll have negative 9x plus 3 times y, which we're going to replace y with 3x minus 4, equals negative 12. Now our next step is just to simplify. So we're going to distribute that 3, negative 9x plus 9x, 3 times 3x, minus 12 equals negative 12. Now this is looking very similar to our last problem. Negative 9 and positive 9, those are going to cancel each other out. And here, oops, this is a negative. I just kind of half crossed it out. Maybe I should, let me try crossing that out in a way that's not so confusing. We end up with no x's, but we have a true mathematical statement. Negative 12 equals negative 12. So then we ask ourselves, does this make sense? Yes, it does. It's not like the last one where we had negative 12 equals 5. That didn't make any sense. But negative 12 equals negative 12, that's true. And not only is that true sometimes, like depending on some values of x, that's always true. Negative 12 will always be equal to negative 12. And what that means is that we have just discovered a system with infinitely many solutions. Infinitely many. And that's all we need to write down. And that's the solution. So, when we are solving these linear systems, each time when we're using the substitution method, we solve it the same way every time. We isolate a variable, we plug in the value for that variable into the other equation, we solve, and then one of two things is going to happen, or actually one of three things. Either we are going to get a value like x equals 3, and then we go back and plug that into the other equation to get what y equals, or vice versa. Maybe we find out what y equals first and then we go and find out what x equals. So that could happen, and that's how we know there's one solution. Or we could get down to that we're trying to solve for one of the variables and we get this nonsense answer like negative 12 equals 5, and we know that doesn't make sense, so therefore there are no solutions. Or then the third possibility is that as we're solving, we lose all of our variables, but we get an answer that's always true, like negative 12 equals negative 12. That's a statement that's always true. And so that would mean that we have infinitely many solutions. So that's it. That's the end of our substitution method. And in our next lesson, we're going to talk about an alternative, and you can decide which one you like better. So substitution is the first type, and tomorrow we're going to talk about elimination.